Okay, so we're starting part 3 on section 9.3. So this one says we have 16x squared minus 9y squared plus 144 equals 0, and we have y squared plus x squared equals 16. So what do we want to do here? Well, we could solve this for x squared or y squared and plug it in up here, and we would be fine. So let's just, because y squared is first, let's solve for that. And then we're going to take this piece and plug it in right there. Okay. So when we do that, we get 16x squared minus 9 times, and now our y squared is this, minus x squared plus 16 plus 144, and then that equals 0. All right. Well, here we're going to have to distribute. So we have 16x squared, and then 9 and 1 is going to be a plus 9x squared. 9 times 16, I don't know, 54, 14, and it's going to be a negative, so a negative 144 plus 144 equals 0. Well, 144 plus 144, opposites, they're going to cancel. And so now I just have 16 plus 9, so that's going to give me 25x squared equals 0, or x equals 0. Okay, so another one where x is equal to 0. All right. So what does that then tell us? Well, that tells us we have to plug that into, let's say, this equation, and we can solve for y. So that gives y squared equals, well, 0, basically just equals 16. Well, this one's kind of nice because when we take the square root of that plus or minus the square root of that, we get y is equal to plus or minus 4. Okay. So for the 1x, we get out 2 y's, and so we'll get 0, 4, and 0, minus 4. And again, if we plug those in, 0 times 16 is 0, and then we have 4 squared is going to be 16 times 9, which is minus 144, plus 144 is 0, so that works. And if you square a negative 4, it's still going to be 16 times the negative 9, so it's going to still be negative 144, so we're done there. And 0 squared is 0, plus 4 squared or negative 4 squared is 16. 16 equals 16. So we have the solution there as well. All right. What about the next one? Well, the next one I have already solved for y, and I could plug it in, but then I'm going to have to start squaring things. So that's not exactly what I want to do. I don't want to square a 3 minus x squared. But I could take the x squared to the other side and solve it, and then I had everything in terms of y, and I think that's going to be better than having an x to the fourth and an x squared and an x. So what I'm going to do is I'm going to say, well, let's subtract 3 here, and so y minus 3 equals negative x squared, and now I'm going to take the whole thing times a negative 1. So then if I do that, bring this over, that's x squared equals minus y plus 3. Okay, so I've solved this one basically for x squared because I can plug this in way easier than squaring this and having to try to factor something with x to the fourth. And again, you're just going to have to kind of look as you go and try to figure things out and see what looks easiest for you. And that's what, as I'm looking at that, looks easiest for me. So when we do that, what do we have? Well, now we have x squared is a negative y plus 3 plus y squared equals 9. Well, what can I do here? Well, I can subtract 9 and subtract a 9. And so then writing in descending powers of y, I have y squared minus y minus 6 equals 0. Now, can I factor that? 6 is 2 and 3. If I make y minus 3 and y plus 2, that should give me minus 3 plus 2 is minus 1. That's minus 6. So that looks good. And so this tells me y is equal to 3 and y equals negative 2. Okay. Well, now since this one's already solved for y, I'm just going to go ahead and plug it back into that equation. And so y is equal to 3 minus, and then I have a 3 squared. And so 3 minus 3 squared is 9. So y is equal to a minus 6. Okay, that looks okay. And so then let's see, what do we have? Make sure I've got that Oh, wait a minute. I solved for y. I'm messing up here. All right. Say that. It's like making it too easy. I have it solved for y, but I have to get x. And so I'm going to plug it into this formula. And so x squared equals a negative, well, y is 3, and then plus 3. And so then that gives me x squared equals 0. And so x is equal to 0. So that gives me the point 0, 3. Okay. What about the other one? X squared equals, now I have a negative 2, and then plus 3. And so x squared equals 1. Well, now I can take a square root of both sides. And so x equals plus or minus 1. And so that means if I take a negative 1 for x, I can get a negative 2 for the y. Now, am I doing this right here? For some reason, I feel like, oh, I see what I'm doing. That's a negative y, so it's a negative, because I'm looking at that and I'm like, that doesn't work. All right, so it's a negative, so let's slow down. So it's a negative 2 we plugged in, but it's a negative 2. So x squared is equal to actually 5. All right, so if I look over here, that looks a little bit better, because I was kind of looking at my answers and trying to figure out how that was going to work, and I didn't see how that was working. And so that x equals plus or minus the square root of 5. And so if I have the square root of 5, I get a negative 2. And if I have a negative square root of 5, I get a negative 2 as well. And so I've got 1, 2, 3 solutions to this one. And so that is going to be one where it's going to be intersecting. If this first one's a circle, it looks like, and this one looks like a parabola, then it's probably going to be something like that, where we have 1, 2, and then the 3 touching here. Okay. And so that's, and again, this is not in any relationship to any space. And then, in fact, I think because that's a negative, it should be going down. But we're just kind of expressing how we're getting 3 points. It's because it's those 3 points like that. All right, so how about this one? 3x squared minus y squared equals 11, and x squared plus 4y squared equals 8. So what do I want to do here? Let's say we could solve for the y squared, plug it in here, and we could do it that way. What we haven't done yet lately, and what I usually do is do elimination. So let's maybe do this one, elimination. And so I can eliminate here because we have opposite signs. So if I multiplied that one by 4, that would give me 12x squared minus 4y squared equals 44. And here I have x squared plus 4y squared equals 8. And so this is, the other way to do it. So, I've been doing all substitution because that was easy, but this one kind of lends itself to substitution or elimination. So, this part here, the y squareds cancel. And so basically I have 12 plus 1, I have 13x squared. Those are gone, is equal to 8, 9, 10, 11, 12, and that's going to be 52. Okay. So if I divide by 13, I get x squared equals, and that's going to be a 4. And so if I take the square root of both sides, x is going to be plus or minus 2. Okay. Well, with that one, now I have to plug back into one of the original equations. Again, it doesn't matter which one. Let's do the second one just because. So if we do that, if we take and say x is 2 or minus 2, we're going to get a 2 squared plus 4y squared equals 8. So that's 4, so I'll subtract 4. And so 4y squared equals 4, divide by 4, y squared equals 1, square root, y equals plus or minus 1, okay? And that's for the positive 2, and if we do the negative 2, we get exactly the same thing. When we square that, that's 4, so we subtract 4 from both sides. We get 4y squared equals 4, and so y is going to be plus or minus 1 again. And so here we're going to have 4. We're going to have 2 will give us 1, and 2 will give us a negative 1. And then we'll have a minus 2 gives us 1, and a minus 2 gives us a negative 1. Okay, and so we're going to get the 4 solutions on this example. And so that means what we have is some kind of intersection where it's going to hit 4 times. Okay. Now we can check, if we check maybe the 2, 1. So 2 squared is 4, times 3 is 12, minus 1 squared is 1, 12 minus 1 is 11. Here we have 2 squared is 4, 1 squared is 1, so 4 plus 4 is 8, and that works. And every time you square positives or negatives, you're going to get the same thing, so it works in all the cases. All right, so that's the end of part 3, and I'll be back with part 4.